Okay. So, let me get you on the balloon. Moving some chihuahuas around. Now I'm going to take a piece of tape and pull that off the dispenser and then move that towards it.
Right.
Okay. So what can you conclude about the tape?
It has electrons.
Opposite charge.
It's not.
It's
It's
either
neutral.
neutral.
Oh, it has
It's
neutral.
neutral.
There's two options.
It's neutral or positive.
It could be neutral or positive.
Right, I remember that.
Okay? Because what could be happening, if you assume that the balloon is negatively charged, right? Now, let's talk about this. Now that you know more about electric fields. If you assume the balloon is negatively charged, what's the direction of the electric field around the balloon? Towards it?
Towards it.
Yeah,
Or
towards
away
it.
from
Finally,
it.
towards
Towards
it.
it.
Towards it.
Towards it. Why?
Electric field assumes protons. Positive. Electric field is positive.
Okay.
Attraction.
Good, Adam. Yeah, I was
There
gonna
might be
say-
electricity.
It pulls it inwards.
There might be
What?
electricity involved.
What is it?
The proton, the positive charge.
Positive test charge.
Positive test charge. Okay? So, a positive test charge, you don't know the value of the positive test charge. So this is why when you calculate the value of an electric field, which is KQ over squared.
E squared, R squared.
So what units do you get?
Over
K is in what?
Newton.
Newton meter squared over. Multiply that by. Divide by.
Meter squared.
You get.
4 joules per meter.
Okay. Coulomb.
Go, gather.
Now, this is why this is what's at the source. Okay, so the analogy can be made if you look at calculating gravitational acceleration, that's big G mass over R squared. Is that mass the mass of the squirrel that I dropped, or the mass of the earth that it's falling towards? Here. So the squirrel is like a test mass, okay? So if I drop the squirrel, I get an acceleration of 9.8 meters per second squared. And what the squirrel is doing, if you think of it like an electric field, so what this is doing is saying, hey, there's an electric field or a gravitational field, there's some type of field existing. Because if I let go of the squirrel to test for the gravitational field, it's like, hey, is gravity still happening today? Let me see. I got the test squirrel, right? False, right? And so I know two things. I know the field still exists because the squirrel accelerates. I also know the direction of the gravitational field because of the fact that the squirrel was falling in that direction. Would the mass of the squirrel make any difference at all in terms of determining the acceleration caused by the field? No. Whether it's Hank, whether it's the squirrel, doesn't make any difference. Because of the fact that this is the mass of what's creating the gravitational acceleration. So, the same thing is, the same thought process is true when you look at electric fields. Oh, okay, right. This is what's creating the electric field, not the value of the test charge. That's like this is not the mass of the squirrel. That's the mass of the earth. So this is what's creating this. Now, how can I find the weight of the squirrel? Fg would equal what?
M.
This value of m, right? This would be the mass of the squirrel, and that would be the value of g. Okay? So clearly, the bigger the mass of the squirrel is, the greater the gravitational force acting on it. So G is not dependent upon what's in the field that you're testing, but the force is. Now, this is also why when you look at electrical force, you can write that as vector. And it's the same idea, because look at this. This is where these ideas are the same. Mass times G, so G is independent of what's falling, but the force is dependent upon what's falling. The same thing is true here. The test charge isn't determining the value of the electric field. It's what's creating the field. This Q is what's experiencing that field. Okay? So this Q here is analogous to that G there. Okay? That makes sense. Now, the beauty of gravitational fields, you have to worry about the direction of it. No. Okay? Like, wow, gravity reversed itself today. Let go of the squirrel, it goes flying up. Weird. Okay? No. You don't have to worry about that. Now, do you have to worry about the direction of an electric field? Very much so. So, assuming that the balloon is negatively charged, okay? Assuming that that's negatively charged, I put a positive test charge somewhere, and this is how I can figure out the value, the direction of the electric field. So if I have a positive test charge, put it here, what's it going to feel?
Go towards the
Attraction.
balloon.
It's going to go towards it, right?
Yeah.
Okay, so that would tell me that's the direction of the electric field, because a positive test charge would feel attracted to it. Now, I take the tape, put it on the table, and let me recharge the balloon, and now I pull that off. Okay?
Wait a minute.
Whoa.
Oh, what?
Same the same
That
charge.
is so weird about
Same charge upon.
Same
Hold on.
charge.
Chill out. Chill out.
Senor.
Okay? Chill out. So, the first time, I just pulled it off the roll, right?
Yeah.
Okay, I just pulled it off the roll. And it attracted to the balloon.
Yeah.
Yes.
This one, I took the same piece of tape, I put it on the table, and I pulled it off. Same piece of tape. No sleight of hand, exact same piece of tape. But now when I bring that close,
It's the wrong way.
what does it do?
It doesn't want to be.
So, what does that tell you about what's the only way two things can
Same
repel?
charge.
Same charge.
Same charge, right?
See.
So, if you assume that this is negatively charged, the only way this happens is now the tape is now negatively charged. So this gained some chihuahuas, right? Okay? That gained some chihuahuas. Where did it come from?
The table.
Table. So the table is now has a deficiency. Now, what can I do to determine if the tape, now that I know this, so this is what we know. We know that if I have the balloon by itself, okay, and I just take a piece of tape off of here, and that tape bends towards the balloon, and we assume the balloon is negatively charged. This is the tape straight off the roll. It comes towards the balloon. Two possible answers.
Neutral.
It could be neutral, or it could be charged. How could we settle if the tape is neutral or positively charged?
The positive thing next to it.
Mr. Nelson.
If it attracts to the
No,
table.
no, no.
If it repels to the positive.
No, no.
Repels from my hand.
Okay, how about just get a second piece of tape?
Huh?
Second piece of tape.
Oh, I take a second piece of tape.
Wait, look what he's about to
No, 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 no,
say.
no,
Look
no,
what he's
no,
about to say.
Okay. Now, now, here's the question. Do I take two pieces of tape off the roll and see what they do?
Yes.
Yeah. Yeah.
Yeah?
So nothing happened.
Okay. So I'm going to do this. Okay.
That might have created.
Hold that, Louise. Okay. And then I'll take another one. Okay. Now, if I try and break those together,
No.
they're repelling each other.
Why?
They're not neutral.
Same charge.
That means they're not neutral.
They're the same.
They're the same charge. They're the same charge. Now, Louise, take yours. Bring needle the balloon.
Louise, you broke it.
Okay. I take this one. Right. Right. So coming off the tape dispenser, they're both what?
Positive.
Positively charged, which is why now we know that they attract to the balloon. If they were neutral, what would happen?
Nothing.
If they were neutral when I put two together, nothing would happen. Okay, so now, Louise, give me your piece of tape. Okay, I'm going to put both pieces on the table. Okay.
I was thinking kill the cat. Curiosity killed the cat. They put the cat in the box.
Okay.
It's like, oh, is the cat alive?
Now, I took the two pieces of tape that we just found were positively charged. Okay? So now I pull them off.
They're both negative.
Because now they're both
Negative.
negatively charged, which is why now when I bring it towards okay. So this is the tricky part about trying to see if something's positively or negatively charged. Because just because it attracts, does that mean that it's oppositely charged? Absolutely not. Okay? But the only way they can repel is if they have
The same charge.
same charge. Okay. No, potassium.
I got silver on my fingers.
Okay. Now, next up. And I've done this, we'll see if it works. That's the a little bit more humid. So,
Oh, the humidity, man.
So we're on zero.
That scare me, bro.
Bottom of that.
Oh, you're talking about
Oh, it's gonna do the thing.
we're going to try.
Well, you got it last time.
I know, yes, last time I did that, the air was really dry.
Yeah, sitting up with your legs on the wall, buddy.
There's a humidity.
Sitting up with your legs
Oh,
on the wall.
that was
after my leg was
Why didn't it because there's more water in there?
Ryan, I used to carry
14 hours away.
I used to carry a fitness drum. I like
90 minutes a day.
I used to carry a fitness drum. I used to carry a little piece of metal.
And yeah, what you could, who am I especially?
Yeah, yeah,
Who am I?
Okay, freshman year, yeah. Hey, freshman year, my bill was
Okay.
insane.
So, if I can make,
Yeah, look at this.
there's just,
There's too much humidity.
yeah, there is.
Drums look.
Okay, but, okay, so imagine if you will, it kind of is.
It is.
Imagine that that's hovering, which actually it is.
There's
Okay.
just like just shoot right
So, this is where we're going to go old school. Okay? If something's going to hover, old school,
Force gravity.
Yeah, how old?
old school.
Like first
That's a good
Oh, yeah.
FB is
So, if something's going to hover in an electric field,
Yeah.
what are the two forces?
Electric force and force.
Your gravitational force and your electric field, right?
Really?
Right? Okay. Now,
Gavin, I swear to signal.
so here's the deal. Let's just say that it has a mass of 0.010 kilograms. Okay? That's the mass. What can you find? So if I take 0.010 kilograms, that's why I said this is old school. Times G, what do you get?
0.09.
0.098.
I knew that.
Now,
0.067.
which direction is that always going to act?
Here.
Down.
Forward to 40.
Down.
Okay? So FG is, no matter what, FG is always going to act towards the center of the earth. Okay? So, clearly, which direction, now, listen to me very carefully. Listen to me very carefully. listening very carefully.
I'm listening carefully.
What's the direction of the electrical force?
Upward.
All around.
Well, technically, it's all around, but
In this.
it's important that
Away
it's
from.
important.
That's going to be acting upward, right?
What other answer?
Okay.
All around.
Now, interesting idea though. Interesting idea. What?
If it hovers, FE is greater.
What?
What?
No.
If it's
Zero
all the way
net
by that
force.
pixel. I mean, if it flies.
What's
up, bro? What's in the top 10?
You know what? How about we let the teacher teach?
My bad.
You're not the
Yeah,
one
yeah.
who's teaching us.
Nathan, it's okay. I still love you, bro.
Okay. Okay.
What teeth, bro?
Now, let's posit two ideas. First off, what are the two ways that you could calculate the value of the electric force?
Math.
You could FEC, right? Right? Good. Which sounds weird unless you're talking about electric field. Now, which charge is that going to be?
That charge.
The
The same.
The charge on
Not the
from the
source.
source,
Not
The
the source.
source.
or from the
source.
charge
What fuel is
that's
it?
feeling it?
That's feeling
The
it.
source.
That's feeling
The
it.
source.
That's feeling it.
Source.
That's feeling it.
Feeling
That's
it.
feeling
Feeling
it.
it.
That's what's feeling it.
Yes.
Okay? So that would have to be like the charge on the plastic that's levitating. Okay? So that's what's levitating. Levitating. Completely ran out of room on that one. Okay?
Oh.
What is
What's
that?
the
Oh,
other way
levitating.
that I can
No,
calculate the force?
Cake.
Is that like, and then
The other option I can
Yeah.
use K, Q1, Q2 over distance squared or R squared, however you want to put it, right? So those are the two options to find the value of the force. Now, let's say we want to go with this one. Okay? So if I know that it has a mass of 0.01 kilograms, and I know the value, so I know the value of the gravitational force acting down. Okay?
I thought you asked me.
And let's say that it's charged to 10 nanocoulombs. A positive 10 nanocoulombs is that. Now, what's the direction and magnitude of the electric field that makes it hover?
Up.
That makes it happen.
Up. Finally.
Makes it hover.
Upward.
I have a two.
All
Man,
around.
what'd you say?
It's up at 0.098 newtons.
Why'd you get 0.08? Now, so, hold on. You're giving me a whole bunch of information at once. So let's start with the direction. How do you know that it's upward?
Because it's going to cancel out gravity.
Okay. This has a positive charge on it, right?
They repel.
It's above a negative, so it's going to repel. Or above a positive, so it's going to repel.
So if I had a positive charge source down here, right? Creating the electric field, right? A positive charge, if my field is down below, the field repulsion. Right? So if it's positively charged, the field would be directed upward. Okay? And we can find the value of that because we have 0.098 newtons. That's my force. I don't know E, but I know Q is 10 nanocoulombs. But can I leave that in nanocoulombs? No. So that's 1 times 10 to the -9. And now I have coulombs. So how am I going to get E by itself?
Divide.
Divide. Oh, look at the units. I get newtons per.
Coulomb.
Oh.
That's
Wow. I get newtons per coulomb, which is what the electric field is measured in. Okay.
Whoa.
Now,
Oh.
what if the charge had been negative 10 nanocoulombs?
They would attract. They would go down.
Would the field still be directed upward.
No.
It's
Aiming
like
down.
10 centimeters. is 0.1.
The yield would be upward, but because the field would be from a positive test charge, but the attraction would be, it's negative to the attraction.
What was the question?
Down.
What was the question? Mr. Bird,
Wait,
what was the
That was
question?
supposed mental gymnastics.
Big word.
Down.
Okay.
Negative, down.
Yes.
Attraction.
Just back up the electric bus. Okay? If it's negatively charged, okay? This, leave the balloon
What's
out.
this?
Now, what's hovering is now negatively
Oh,
charged.
wait, it's hovering
So
over
what?
It's the exact same ball.
Oh, it's hovering
That's a
over
ball.
the
It's
balloon.
the exact same ball. Okay? It's the exact same ball.
Yes.
Same mass. So is the gravitational force still the same?
Yes.
Yes. Okay?
You're trying to touch me inappropriately.
I was
defend
not-
myself.
Taking a timeout in flag play.
That is
I was
a right.
not doing that.
I was
not doing that.
Why-
I thought.
Hey, that's like
Why-
you're
why
going
is
to
your-
jail.
No, run it to me, run it to me.
Go see human resources.
Now,
What's going on?
if it was negatively charged, okay? If it, can we just turn the freshman dial down a couple of notches today? God. So, I need to start like a freshman scale for this class.
Oh,
Like
do the-
where you're at on the freshman
Do it like-
scale.
do it like
Wait,
good or
the-
bad.
the-
Yeah.
the-
The markers.
Yes. Remember you said you wanted that.
Like the clip?
You said you wanted the
I don't
clips.
even want to.
Yeah, and you like fit it like
Oh,
how.
yeah, there you
Yeah.
go, yeah.
Yeah.
Do we actually get one?
I might make one.
Yeah, we should.
He needs that, bro.
Yo, you need to add that.
Please.
Do it.
It's the funniest thing.
No, this is collectively for the class, not individually.
It's like senior level, junior level, and then there's just
No, there's just freshmen. Like how high you go on the freshman scale.
A superlative, if I like bring the scale up the most.
that should be a competition.
Like if I had third, if I bring
It
the
should.
most freshman there, you gotta get like
Yeah,
medal or something. You're 16.
You might get a medal in your arm for this because
Oh, I want to see that.
What is going on with the Oh, like a
Oh.
I broke my wrist.
Okay,
I got that all on video just so you know.
all right. Hey, you give me a jury of 12 physics teachers, I will walk. I promise you. Okay?
All
right.
Get us Kim on that.
So if it is negatively charged, is gravity still pulling down on it?
Yes.
Yes.
Always.
Now, if the electric field was still pointing upward, what would it do?
Wait.
Listen to me. I'm going to take a negatively charged object and I'm going to put it in an electric field, and the direction of the electric field is pointing upward. Can it levitate if the direction of the electric field is pointing upward?
No.
Absolutely not.
No.
Why?
Because there's a positive test charge, so your
Yeah,
thing
So
is
the electric field is based upon what?
positive test.
How a positive test charge responds. Okay? So if I put
Anything but
toys,
Yeah, your spark tape and your rotating platform and your gigantic gyroscope, buddy.
Hey, you should
I know
put
that.
Mr. Burkett,
it's like Christmas.
I kinda, is this the one where you stand on it with the weights?
Yeah.
Yeah.
I want to put a.
No.
I remember that.
Dang, he said no so quick. Did you hear? He said no.
Okay, I'm going to establish for this class and this class only a freshman
Bro, why would
scale.
you?
Slide the scale.
God, you
Flip
guys are
up
terrible.
and flip
That's
down.
what
Yeah.
Yeah, we need a contract. That would be good.
Stop. Get me out.
I'm looking at one.
Ooh, this smells bad. I think I just got kissed.
Okay.
Get away. Hey, get away.
Hey, they'll be at the
See,
top.
those are the freshmen.
Yeah, the freshmen over there.
If it makes you feel better, this is tame compared to what they were last year.
Hey, that is.
Last year, I took Chem 2 2
Hey, I
years
didn't
ago.
do
Don't
it.
ridiculous.
Between us.
You're not the problem. It's them. He's
Whoa,
15.
whoa,
No, I know
whoa,
it's not
really?
you. Ask
Really,
me
Mike?
how many times between Adam and Nathan, and honestly, sometimes Shannon himself asked me how many times I had to say, guys, that's racist. We don't.
No, 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 no.
Adam.
How about we go do our job, alright? Why are you over here?
Hey, I kind of want to learn this lesson today.
I know it's cool.
I would really appreciate being able to know how to do my homework, so that'd be great.
Ask me who's staying in Flex on Friday. Ask me who. Ask me who's gonna get a disciplinary roll right now.
Okay.
I'm
Anyway.
gonna go do my job and put in a referral.
All right.
She wrote me up twice today.
Back to our story. So, if you look at how an electric field is defined, okay, how is an electric field defined? By what a positive test charge would feel. So if you put a positive test charge in this field, it would feel a repulsion. So if you put a negative test charge in it, it would feel an attraction. So I cannot make this hover with the electric field pointing upward. Now, what if the electric field is pointing downward?
Go up.
Yeah.
Go up.
This is counterintuitive. Because if you put a positive test charge and it's directed downward, what's going to happen?
To the negative.
It go down. It would get pushed down. But if the electric field is pushed down and you have a negative charge in it,
It go up. It go up. It go
it
up.
would go up. So this is counterintuitive because to make it hover with a negative charge, the electric field actually has to be pointing downward to make a negative charge feel an attractive force. Okay? Go with that. Okay.
That better not be on the test.
Huh? Oh, absolutely.
Take it off the test right now. Take it off.
Can I give you a specific paycheck?
Negative charge, it was no cover.
Okay.
No, you
So
can't.
let's say that
It's gotta
I'm going to
have the
have
positive charge
two
Like,
positive
Feel
charges.
feel has to be positive?
And I'm going to look at point
No,
one,
like, the electric field would be like
Here.
pushing down. Like,
point
pointing
two,
down. If
and
that
then
makes
point
sense.
three.
Whoa, too low.
Okay?
don't understand.
Assume that all these distances are equal.
Do the point of charge.
Okay. So, how would you describe the electric field that each one would feel? This is based upon electric field, not forces. Electric field. So which point would feel the smallest electric field? Why?
Oh,
That's not a.
They canceled.
Because they cancel out.
We're going to cancel out. So point two in the middle, assuming that everything is the same, so point two in the middle would feel what?
Zero.
No net electric field. Okay, it would feel an electric field, but it would feel an equal push from both sides. Okay, it's kind of like your hand. You don't feel a difference in atmospheric pressure because of the fact that the pressure is the same on both sides. There's no net electric. There's no net pressure. Same thing as this. What would three feel?
Push
Like,
away.
it's like the positive
Pushed
charge,
away?
like pointing down.
Yes.
Which one would be providing more of that repulsive force?
Closer one.
The closer one or the one further away?
Closer one.
Closer one. So it's going to feel a push this way what about 1?
Same thing the other way.
Would the magnitudes be the same?
Yes.
Yes.
Assuming the same.
Assuming everything
He
is the same.
told us it's
Okay.
the same.
Now, what if I did this? I did a positive and I did a negative and did the same thing.
Ooh.
Different stuff.
Wait.
Oh, wait.
I like asking us
Two would be the charge.
That
Two would just stay.
Would
Yes,
two
two would
just
just stay.
stay there?
Two- yeah.
No, two goes
big that
Two would
way.
go
Go that way.
Trust me.
Okay, hold on. Hold on.
Charge is the same.
Let's start with what's going to happen in the middle. So, what is 2 going to feel from the negative charge?
Attraction.
So 2 is going to feel a pull in that direction, right? What's it going to feel from that positive charge? So that would both be pointing in that direction. Is it going to cancel out?
No.
No,
They add up.
because they add up.
But both.
Okay. Now, what about at point 3? Just relative to the negative charge, what's it going to feel?
Attraction.
It's going to feel an attraction from that, okay, right? But what's it going to feel from the positive charge? A repulsion. Is that repulsive force going to be bigger or smaller than the attractive force? Smaller. Why?
Radius is shorter.
The distance is bigger. And if you look at that, that's KQ over. So any changes in the radius play out large because it's square.
That's E, right?
Yep. So this one is going to feel a little bit of repulsion, but not much. Okay? So it's going to begin to move in that direction. What about 1?
Like repulsion, but also
Slight attraction.
So it's going to feel a lot of repulsion, but a little bit of attraction. Okay? All right? Kind of like probably what most people feel towards freshmen. A lot of repulsion,
No, it's
Yeah.
attraction.
What? Unless they're other friends.
Okay.
How do you feel?
All right,
That's a
no,
crazy
all right,
sentence.
stop that for a second.